Okay, we're going to do 1635. It says determine the apparent weight. So the apparent weight is going to be, when we look at our free body diet, it says for a 60 kilogram person riding in an elevator. So there's different scenarios. So here's the elevator. My weight is going to act down, and then my normal force is going to act up. So the apparent weight is the reading on the scale, which is the normal force. Okay, and that's the key to this. Now, in the different scenarios, the free body diagram is actually going to be the same, but the most important part is we want to make our sign convention going in the direction in which the elevator is moving. That's the key to these problems. All right, so let's read it. So it says moving upward at a constant velocity of 2 meters per second. So first of all, you have to read carefully. Constant velocity, that means the acceleration is 0. So what does that mean? Well, when I look at my free body diagram, the first thing I want to do is I want to draw my sign convention. So I'm just going to call up positive. So I'm going to say summation of f of y is equal to ma. Now I know that this is moving at a constant velocity, which means the acceleration is 0. For me to get full credit on an FRQ is I actually have to write is equal to 0. Because that's a point and that's a point. Now, I'm going to look at my free body diagram. So I'm going to do this neatly so when somebody is following my work, they can see what I did. So I'm going to look here. I'm calling up positive. So Fn is pointing up, so that's positive. Fg, the weight, is pointing down, so that's negative. And that's equal to 0. So now I've got another point. Now I want to solve for the apparent weight, which is the normal force. So here, Fn is equal to Fg, which is equal to mg. So Fn is equal to 60 kilograms times 9.8 meters per second squared. So that's equal to 588 newtons. Now this would be the same reading on the scale if the elevator wasn't moving, if I was standing still. And because I'm moving at a constant velocity, it doesn't matter if I would be moving up or down, that would still be the same reading on the scale, because the acceleration is 0. All right, let's read part B. So B says it's coming to a stop at the top floor with an acceleration. So because it's coming to a stop at the top floor, we know it's moving up. And because it's moving up, that means I'm going to make my sign convention up. So I'm going to say summation of f of y is equal to ma. This is not equal to 0. Now, because it's coming to a stop, that means my acceleration is going to be negative. But I'm not going to substitute that in yet. Okay, what I'm going to do is I'm going to look at this problem. So now I'm going to rewrite this. And bless you, I'm going to look at my free body diagram. So Fn is positive minus f of g is equal to ma. So this is a point, this is a point. So now when I rearrange this, I want to solve for the apparent weight, which is the normal force. So f of n is equal to ma plus f of g. All I did was move it to the other side of the equal sign. When I skip intermediate steps, that's how I make a mistake. So now, a lot of times on the multiple choice part of the AP test, what they're going to do is they might ask you a situation like this, but it might be in terms of variables. So you do not ever want to get in the habit of just plugging numbers in. That's how you make mistakes. So what they will probably ask you is, we know that f of g is equal to mg. So they might ask you the answer in terms of this, that they might ask you just in terms of variables, and that, let's say, might be the reading on the scale. Because let's say they don't give you the acceleration. Okay? So that's why we need to know how to do it like this. Now, if in this case we want the actual value, so I'm going to say f of n is equal to 60 kilograms times the acceleration, which is negative 1.5 meters per second squared, plus 9.8. Now, why is this 9.8 positive? This is positive because in my free body diagram, I already drew it going down. So I've already taken that negative into consideration by having that force go down. So I'm not going to put it negative again, because then I would be doing a double negative. Once I put the sign, the direction into consideration, I do not do it again. It's already into consideration here when I made this negative. So then when I do this, this comes out to be 498 newtons. So that apparent weight is that's the reading on the scale. Okay, part C. So part C says now it's accelerating downward at 1.5 meters per second squared. So because this elevator is moving down, what I'm going to do is I'm going to draw my sign convention going down. So I'm calling down positive. I'm saying summation of f of y is equal to ma. Now when I look at my free body diagram, if down is positive, what that means is f of g is positive. So now when I rewrite it, I'm going to say f of g minus f of n is equal to ma. The worst thing that you could do is try to memorize like equations for all the different scenarios for an elevator. Accelerating up, accelerating down, that just doesn't make sense. You want to understand it. So now when I rewrite this, I know that f of n is equal to f of g minus ma. Remember, in our free body diagram now, even though this looks the same, now I'm calling down positive. So that's why fg is positive and fn is negative. So now when I substitute in my values, I'm going to have fn is equal to mg minus a. So it's going to be fn times 60 times 9.8 minus 1.5. The 1.5 I'm calling down positive, so that's why that is like that. So Fn comes out to be 498 newtons. And then our last scenario is D, and it says it's decelerating down at 1.5. So I'm going to have my same sign convention I did before. I call down positive. Summation of f of y is equal to ma. So now I'm going to look at my free body diagram. Down is positive, so I have f of g minus f of n is equal to ma. So now I rearrange it. F of n is equal to m times g minus a. This is where you have to be careful with your sign convention. So Fn is equal to 60. Now g is 9.8 minus a, but a is negative 1.5. So a negative and a negative is a positive. So Fn comes out to be 678 newtons. And that's it. So with this, you draw your free body diagram, even though they're going to look the same. And the most important thing is, which way is that elevator moving? Okay? So I have to be very careful with my sign convention. And then in this case, I have to be very careful with my signs, like between this and this. And then my normal force is my apparent rate, which is my reading on the scale.
Wait, were you the one